Our second practice problem from section 12.1 is number 7. Number 7 gives us the following 3 points: 2, 2, 3, 8, 6, 5, and -1, 0, 2. It basically asks us to find the length of the 3 sides of the triangle formed, but then it asks us a suspicious question. Why do the results tell you that this isn't really a triangle? So let's take a look. The distances I'm going to calculate by just arbitrarily assigning these points the values or labels A, B, and C. So AB would be equal to the square root of 8 minus 2 is 6, that's 36. 6 minus 2 is 4, that's 16. And 5 minus 3 is 2, that's 4. So that's 20, 56, the square root of 56. And 56 is 4 times 14, so this would be 2 radical 14. Okay, BC is equal to the square root of 8 minus 2 is 6, that's, oh no, sorry. -1 minus 8 is -9, squared is 81. 0 minus 6 squared is 36, and 2 minus 5 is -3, squared is 9. So this would be 45, and that would be 126. So the square root of 126, which is also a multiple of 14. This is 9 times 14, or 3 radical 14. And then finally, AC. AC would be -1 minus 2, that's 9. 0 minus 2, that's 4. And 2 minus 3, that's 1. And of course, that is the square root of 14. And then we can see the problem here. If I add AB and AC, I actually get BC. That is, AB plus AC is equal to BC. And that's the reason why this guy just barely makes the criteria for a triangle. It's not really a triangle. There's this thing called the triangle inequality theorem, and it basically says if A, B, and C represent 3 sides of a triangle, then A plus B has to be greater than or equal to C. That is, the sum of any 2 sides has to at least be the length of the 3rd side. If they don't quite make it, then of course the triangle won't be a triangle, because 2 of the sides added up won't be as long as the 3rd side. So it's not generally possible for any 3 endpoints to represent the 3 sides of a triangle, or any 3 segments. 3 endpoints will always represent a triangle, but this is sort of that unique case where we're using the equal to. The graphic at the right will show you that, in fact, if we plot these 3 points, then they do, in fact, make a straight line.